Here we go. We have a question. Next permutation. So you have given an integer array representing a permutation, and we need to implement the next permutation that rearranges the number into the lexicographically next greater permutation. If no such permutation exists, we need to rearrange the number into the lowest possible order, which means sorted in ascending order. Note here is a permutation of an array of integers refer to a specific arrangement of its elements in a sequence or linear order. So what it means is we need to find the next permutation for any given sequence. So let's take an example of this. In this, the next permutation will be the 5 will come at this position, and after that all the elements will be sorted. So we have 5 and all the elements is in the ascending order, and if no such elements exist, if no such permutation exists, we need to rearrange the number into the lowest possible order. We will talk about this case separately. So let's directly jump into the approach. Suppose we have this, and in this the next permutation will be 2 3, then we have this, so this 6 will come here. So what we got is this, this is our answer. So how do we find this? We start from previous, and we check, is the current number, less than to its next number? Yes, in this case we have a number here, so this is our first point. Then we need to check the number just greater than, this current number on the right hand side, and we will start from back. Why do we need to start from back? Because while starting from back, the first number that we got will be placed here. So we have this number, and this number will be swapped with this number itself. Then we got this 2 3 1 4 6 and 5. So this is our answer in this case. Let's talk about this case. In this case, is the current number less than next? No. Is the current number less than next? No. Is the current number less than next? No. Is the current number next than less? Yes. So our first number is this, and let's find out the next number. We start from previous. So is this number greater than this? No. Is this number greater than this? Yes. So this number will come at this position. This number will come at this position because we need to find the next permutation, and the next permutation is in the lexicographically greater order. So we got this number, and let's swap the numbers 2 4 6 5 3 and 1. Now we swap this number with this number, and all the numbers on the right hand side will be reversed, because this number will be here, and after that all the numbers is in the ascending order, because this is called lexicographically smallest. So now let's reverse the number after the PT1 point. This is PT2. So reverse all the numbers. We got ascending order. So this is our answer. We need to sort it. Sorry, I talked. I said reverse. We don't need to reverse. We need to sort the array uh, after the PT1 point. So we got this, and this is our next permutation. You can verify. You can verify the answer. So now let's talk about the sample test case that is given in the problem statement. We have 241750, 24175, then 0. Is this number less than next? No. Is this number less than next? No. Is this number less than next? Yes. So we have this number, and this number will be swapped with the number just greater than this number on the right hand side, and we start from back. This is the first number that we encounter, so we need to swap this value. So we got 2 4 5 7, then we have 1, then 0. So we need to sort the array after the pt1 point. This is pt2. So after that we got this. So this is our answer, 245017. So 245017. So what if we don't find any pt1? So we have a case like this, 4 3 2 1, and let's take 0. Is this number less than next? No. 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 So our pt1 will stay on n. If we find any number which is less than its next number, we initialize our pt1 to the ith value. But in this case, our pt1 is n itself, so its next permutation will be sorted order. So if our pt1 stays on n, we just need to sort the input array. So let's say nums. So that's how this approach will work. Let's code this. So we have n and pt1 initially pointing to n. Then we start from n minus 2 position. Why? Because we need to check with the next value. So if the current value is less than next value, then we initialize pt1 to the ith value, just break out from the for loop. Then we need to check, is the array in the descending order, which means pt1 pointing to n. If this is the case, we just need to sort the array and directly return the answer. So this is the case we have here. If no permutation found, we need to rearrange the array into lowest possible order. So we got this. If pt1 is pointing to some index, then we need to find pt2 itself. So we start from the back, and you can either go to 0, or you can either go to pt1 greater than I will be greater than pt1. So that will also work. If the current value is greater than pt1, if the current value is greater than pt1, means we have found pt2, and then just break out from this condition. And this is the condition where we need to swap the values. After that, just sort the array after the pt1 till n. So we got our next permutation. So now let's submit this, and this will work fine. And let's talk about time and space complexity. In the worst case, if we don't find any pt1, it will sort the whole array, or you can say it will reverse the whole array, because the elements is in the descending order, and we want the elements in the ascending order. So you can either reverse or you can sort it. So reverse will also work. In the worst case, it can go till n log n, but you can optimize it to log n. And let's find out. Time complexity will be log order of n, and space is constant. So instead of this, you can just reverse the whole array, and space complexity is constant. So I hope you have learned something new. Give this video a thumbs up. If you like this video, give it a thumbs up, subscribe to this channel, and thank you all for watching.